Hello. Thanks for joining me on this talk about wildfires. I'm going to start off a little bit about me. I currently work at a company called Red Zone, and I'm on a team where we deal with wildfire risk. So we give a wildfire risk score on, the risk of a location for insurance companies. And then other than that, I am the regional executive for North America for Black Python devs, which was talked about a little bit earlier. So if you want to connect with me, here's my LinkedIn. Feel free to reach out. If you have questions about Black Python devs, if you have questions about this talk, I'll give you a second for that. And so for this talk itself, here's the GitHub for it, but hopefully by the end of it, you have a high-level understanding of wildfire terminology. I hope that you have like a broad sense of the capabilities of Geopandas, and then the basics of mapping with Folium. So to start off, we're going to start with the basics of geospatial data, right? I mean, I think by now most people have some type of use for geospatial data. You've probably used a map. You've probably used Google Maps if paper maps aren't your thing. But really, it's just any data that has a component that is related to a location on the Earth. So in this example here, we have a shake map from an earthquake, and a few of the geometries that you'll likely see are something like a point, a line string, or a polygon. Polygons, for the most part, are what you'll probably see with wildfire perimeter data, but you can also have collections of these things, so multiple of them, so like a multi-polygon. So that's also not uncommon for wildfire perimeter data to have multi-polygon for one row and then just a polygon for another one. But with geospatial data, I say it's related to a location on Earth, but how do we take something that's like 3D and put it into 2D, right? And so that's kind of like a problem for those of us that think that the Earth is actually round. But I think the PostGIS contributors put it best, right? Like, this is a hard problem to solve, and there's a lot of ways to solve it depending on your use case. Here's an example of how you might solve it with a projection. And I give this link on here just because there's so many projections, and the one that you use is going to be dependent on your use case. Some of them are going to maintain an area or a direction, and so depending on what you're doing, you're going to need to pick a different one. And you might be going like, okay, so we have these like projection things, but why are they useful? Well, if I asked everyone to stand up and take 3 steps to your left, is everyone going to end up in the same position? No. Why? Because you're going to be like, is that your left or my left, right? Everyone's not starting at the same place. So we have to have a way for everyone to understand that, hey, when I'm talking about this thing, this is where we're starting. This is what we mean by, left or right or whatever it is. And so these are spatial reference systems. And these describe where a geometry is on the Earth's surface. There's multiple of them out there. A lot of the times what you're going to run into is this EPSG 4326. I'll tell you right now, the data that I'm going to use comes in this reference system. You're probably familiar with it because lat longs, latitude, longitude, is this reference system most of the time for what you're going to run into in your day-to-day. But with that, let's move into the more interesting, I guess, topic of actual wildfires, right? I think that there's so many fires popping up all the time. You see on the news that there's another new big fire. They're constantly happening all over the country. There's a few things I think people think of when they think wildfires. I think they think a lot of the times of the western 13 states That's not true. You know, you might hear of like wildfire season, like you might hear of a hurricane season. That's not true, right? These wildfires are happening year-round, all over the country. So like those are kind of two myths that you might hear of when it comes to wildfires that unfortunately is just not the case. And I was asking some of my coworkers of like, you know, these are two of the big myths that I think I hear people say the most. There's another one I'll address. I was like, what's kind of the other thing you want people to know about wildfires? And they were like, evacuation zones. And I was like, evacuation zones? They're like, yeah, a lot of the times what we're running into is that there'll be an evacuation zone for a wildfire and people won't leave, right? They see the zone, they think it's huge. They're like, the fire's way over there, why am I gonna leave? So the thing to remember with evacuation zones is that they're that size for a reason. And it might be just because there's that many people that have to get out. It might be that there's only, you know, single road in and out for access points. And you have to remember that, you know, they have to get large machinery in while also getting everyone out with, you know, a decent amount of time with how fast fires travel. So I would, if anything you take away, I would ask that if you are ever in an evacuation zone, if you know someone, have a loved one in an evacuation zone, tell them to leave that wildfire evacuation zone, like please. So, but with that, let's turn to some wildfire terminology. The first one we'll talk about is a perimeter. I think this one's probably the simplest. It's just the outer boundary of a wildfire. Then you have an acreage. I think this one also is, you know, not too bad. It's just the land area affected by a wildfire. But this one, the one I'm about to go to, is the other one that I think gets a big misunderstanding, containment. So you've probably seen on the news with a fire, like the containment value might be 15% contained, and people think, oh, the fire's 15% out. No, that's not what that means, right? That would be like 15% of the perimeter isn't expected to spread, right? So there are different ways that you can make a fire break, which is just a natural or man-made barrier that's gonna help stop the fire from spreading. And that's kind of what this picture is here, is that something like this would be a fire break. You can also, something like a river would be a fire break. A lot of times highways are expected to work as a fire break. You might also hear fire break referred to as a few other things, like a control line. But containment is not that the fire is out, right? The fire is still active. A fire can be contained and still active, right? That just means that, hey, we have this area now that we don't expect the fire to spread outside of. But if we want to talk like about a fire being out, you know, sometimes you might hear out, but controlled. And so a fire is in that control line, that containment zone, but it also has no hot spots, right? They are confident this fire is not going to start back up. So a fire can be contained and you don't see any flames, but they still go around knocking out hot spots. So I think like that's the other big myth you see people talk about when they see fires on the news. And then this one now I'm going to go to is a little abstract because it's not so much to do with wildfires as much as like the systems for reporting them, and that's IRWIN. And so IRWIN is a system that was put into place to help aggregate all these disparate systems that people had for reporting wildfires. And it's kind of just they're like, we need a way to get all this data in one place. And the reason I bring this up is that a field that you are likely to run into when you pull wildfire data is this IRWIN ID. And that's a unique identifier that IRWIN places on an incident. And that uniqueness is helpful because different data sets are going to have different fields that you're interested in, or they'll have the same fields, but one data set has better values for those fields. And so you might have to merge that data, and being able to deduplicate on something when you're like, I don't know which one of these records is newer, it's helpful to have that ID that you don't have to implement yourself. So that Irwin ID can be very useful when you're dealing with this data. So if we now look at the wildfire perimeter data itself, probably I would suggest the best place to get it, and the place that we'll be focusing on, is NIFC, the National Interagency Fire Center. This is probably going to be the authority for fire data. If you're looking for data, this is your first stop. If they don't have what you need, then you probably know what you need, and you probably have an idea of where to get it that you already know. So, but with this perimeter data, the other thing I kind of want to touch on, and would probably like the last myth I want to talk about, is that when you see wildfire perimeter data, especially on the news or something, that data can be old, right? Places that have the ability to report often and have the infrastructure to do so, a state like California, you might get a fire update 3 times a day. Other states, depending on the state, location, fire, you're lucky to get an update every other day, and it's not uncommon to get an update once a week, once in a few weeks. So it is very possible that you look at a wildfire perimeter that is for an active fire that's days, weeks old. So I think that is something to keep in mind, that a lot of the data you're seeing is not real time. It's just not. But let's take a look at the site and see kind of how we would get the data. So here I'm on the NIFC site for this wildfire data, and the data that we're going to be pulling is this interagency fire perimeter to date. I pulled the data 2 weeks ago, so not quite to date, but so it's going to be everything for 2025. And this is the info page for it. You can go through, they tell you what that data is, kind of where they took it, what they're expecting it to be. So for this data set, this is focusing on the best perimeters that they have available. The other data is a little but the perimeter data is the best data that they have. And also on here, you can explore all the fields that will be in this data set, including definitions, which is helpful because, even just from this screenshot, you can see that there's already a lot of them. There's also another field on there for data types as well. I think the thing that I really like about the way that NIFC does it is that you can also just explore the data right there in a table format. So you can go through and kind of see what data's in there, what it looks like, which is nice before, some of these data sets can get very large before you download them and work on them yourself. The final thing that I want to point out is that they actually allow you to see a map of that data right on the site. Some of the larger data sets, you're really going to have to zoom in, there's too many records. But it is kind of nice to get an idea of what you're looking at, because some of them will be perimeters or polygons, and some of them are just points, right? And so you might go in, I've done it. I've downloaded a whole data set, go throw it into QGIS, and it's just points, and I'm like, I need boundaries. This is useless to me. So, but that's all fine to look at the data here, but we want to do it with Python. So in order to do that, we're going to use a library called Geopandas. Geopandas is just an extension on pandas. So if you've worked with pandas, this is going to be very familiar, but Geopandas adds geospatial support. With pandas, you're going to work with a data frame, Geopandas, geodata frame. I probably will just say data frame today, but if you see that, it's really more or less the same thing, but with a geometry field of some sort. Alrighty. So the data I pulled directly from NIFC, I did pull it as a GeoJSON. There's a lot of different file types that you can get geospatial data in. GeoJSON's just JSON, but the two things that I want to point out is that we have this geometry on object here, but then we also have these properties. And the properties are going to be all of our field names. I just want to point it out because it's going to come up in one of the examples where like I randomly now have like a properties column, and you're like, you never had a properties column, but it's coming from the GeoJSON itself. So we can start very simply just loading our data, right? So we're going to just import GeoPandas as GPD. If you work with pandas, you usually import it as PD. That's pretty typical. So GPD here. And so I just have this WF perims raw, wildfire perimeters raw, that I'm just GPD, read file, and I give it the GeoJSON file, right? And if I do a .head on there, you get an output, and you can see, you know, all the middle columns there are missing, but we have a geometry, we have some type of ID, we have some data, so it's a good start. We can also explore the columns that are in our data frame. And so we can use just a to-list, and I have an output here. We have all these columns. I'll let you know that it's 119 columns. It's a lot, and so if we want to clean this up, you might be tempted or used to using like drop. I'm not going to do that here because I don't want to list out that many columns to drop. So instead, we're going to make a new geodata frame using these columns, but I'm going to use .copy, which is going to be a deep copy to give us a completely new object, so we're not overwriting our original object. Now we have our data loaded. We have the fields we want. We need to clean the data, right? So we're going to do a very simple cleaning here. I'm just going to replace these missing values with 0 because I'm going to need to do some quality checks on them. So I'm just going to fill them with 0. If you're really working with your data, you might need to just drop those rows. You might use a min, a max, an average, something like that to fill this data. But so we have this estimated cost to date, which is the firefighting cost. I'm just going to set all the missing values to 0. Same thing for the GIS acres. So that acreage, I'm just going to set it to 0. You might be thinking like, well, you already have the geometry. Why don't you just take the area of that geometry, and that's going to be those reference systems, right? And I don't want to do conversions right now. We don't have like time. It's a little confusing, so we're not. But just know that with the spatial reference system that we're in, areas are not very good. So I'm just going to set it to 0. The other thing you might want to check is whether or not a geometry is valid. All of our geometries are valid, but GeoPandas does have this is valid reason, which will give you if a geometry is valid, and if it's not, it'll give you the reason why it's not valid, which can be helpful, especially if you need to like retain all the records that you have. You can also filter data. So just as an example here for the like acreage, we want only the acreage above or equal to 20 acres. Same thing here with the estimated cost to date. You might only want over 100,000, right? Just for dramatic effect, I'm just keeping all the data for the visualizations. But this is something that is very useful to do when you're exploring these data sets. So we now have like this clean data set, but how do we actually map it, right? And so for that, we're going to use Folium. And Folium is a library that uses Leaflet.js for making maps. Once you have it, pip installed, you can just import Folium, which is nice. So import Folium. Here we have this Folium.map, and we have these three fields we're going to fill in: location, tiles, zoom start. Location is where we're centering our map at. Tiles is going to be our, in this case, our like background for our base map, and then the zoom start is 5. So if we run this and we map it, we're going to end up with a map that looks like this. And you're like, that's really dark. Like, why would you do that in a presentation? I have a reason. So we have our base map, and now what we want to do is we want to actually add our fire parameters, right? So under our base map that we have, we're just going to add this folium.geojson, and then we're just shoving our wildfire perimeter data frame directly in there and adding that to our map. That Folium GeoJSON makes a GeoJSON object for you, and that's where I mentioned that like properties thing from earlier. But if we did that, then you get something like this. And you go, okay, that background map's still hard to see. I know. But also, what do you see when you see this map, right? Like a lot of dots. It's not telling you very much. If I said, what state has the most fires? Where's the biggest fire, right? I don't know, right? It might be a little surprising to you that like Florida has fires. You maybe didn't know that. Or the number of fires up in like Wisconsin. But this really not telling us too much. And so we probably want to add some styling to this. So add styling with our Folium GeoJSON, right? We have our data frame, but then we have this style function. And we can add a fill color and a color, and that's going to change the fill of our polygon, our perimeters, and the color is for the border of that polygon. We could set it to red. That wouldn't really help because we just end up with the same map that's red, but we probably want to style based off of some properties of our data set. And so for that, we have this, we're going to replace our red with color map size, and then you notice that properties, that comes from that GeoJSON. And then for this, in this example, we're going to use acreage, right? So we have this poly GIS acres that we're going to use for both the fill color and the color. And you might be going, where's color map size coming from? And color map size is coming from this Bronca library that comes as a dependency with Folium. And this is just going to allow us to create a gradient of colors for, in this case, acreage, right? So our colors that we're choosing is green for the smallest fires up to red through yellow and orange, but red for the largest fires. We have a min value and a max value set to the quantile 0, which is just going to be the minimum value, and the quantile of 0.9, which is going to say all of our 10% largest fires are going to be red. And so if we were to map this, now you end up with something like this. You go, okay, I can't really still see the states, but just from this, you can now see that like, ooh, there's a lot of fires up there, but they're all small, right? And whatever's happening down there in Texas and New Mexico, like there's a lot of large fires going on from this year over there, right? So just by adding that little bit of color, you start to be able to see a little bit more from our data set. But it would be nice to like now explore a little bit more. So we can add a pop-up field. So when you click on the map, you actually get information on whatever fire you clicked on. And so for this, we're going to do the incident name, the acreage, the cost, and the Irwin ID. But we're also going to alias it so that on that pop-up, we have names that are more human readable or would make sense if you're sharing this with someone. So we're going to go with incident name, acres, cost, Irwin ID. And on our folium.geojson, we're just going to add this pop-up equals that pop-up that we just created. If we do this and map it, you get something like this, where now you click on a fire and you have a pop-up with the information, which is also nice. But I did spend a good bit of time talking about geospatial data, so like maybe we should use GeoPandas to do something with geospatial data. And for that, I'm going to pull in a data set that's just the states with their geometries, and I'm getting this data set directly from the Folium example data. So I'm going to pull that in. You can see here that it's just the abbreviation, the state name, and the geometry. But what we're going to do is I only want California, Texas, and Alaska. Those are the only states I want. So we're going to filter that state data to just these target states, and we're going to get the fire perimeters from those states by using an intersection, right? And an intersection is just, do any two geometries have a point in common? And so we have the wildfire perimeter data. It intersects our target states. Notice this union all. Union all just takes all the geometries and mashes them together into one geometry. So instead of having to actually go through all of them, I'm just going to force them into one because I don't care what state it's in. I just want those 3 states. So if we take that, and I'm going to be nice, I'm going to do a light map now. So notice that I changed my map to that CartoDB positron. But we're going to take those filtered wildfire perimeters, do the same colors based on acreage that we did before. We're going to add this to a map, and you get something like this. And you go, whoa, I forgot that Alaska even existed and had fires because you didn't show it. But not only does it have fires, it has a lot of very large fires. Alaska gets a lot of large fires, right? And we can see that. But we also see that now we only have the perimeters in Alaska, California, and Texas, just like we wanted. I think I still have time because I want to show one more. I want to point out one more thing here that we can do to make this even better. So here, what we want to do is, so here, we're going to make a new base map, right? But notice I have tiles equals none. I'm not setting any tiles on it, but instead I'm going to add two different base map tiles to our map. So I'm going to do an OpenStreetMap and then that same light map that we had in that last example. So most of this is going to be the same, but I also want more information now. So I want to see how many fires does a state have, right? So I want to create a new column that I'm going to call fire count. I'm going to use the intersection again for all the state geometry, and I'm going to sum it so that I get the number of fires that happens in a state. And if there aren't any, just give me 0. But we're going to do that. We're going to color those green to red, the same that we did before. And the other thing I wanted to point out here is that we have this folium layer control. And this layer control is going to allow us to add toggles to our map so that we can choose what we're seeing. And so if I exported this just to HTML. Oh yeah, so I'm in. So we have this base map here that has nothing on it. Our OpenStreetMap. We can change it to this CartoDB map if we want. The other thing that we can do is we can pull up just our perimeter data like we had before. We can see if we click on it, we get a pop-up. You can zoom in, get an idea of the actual geometries. Maybe you want to explore. You're kind of like, oh, what is this little policy out here, right? There's a cottonwood. Is that the same to this? Oh, no, these are different because sometimes you will get perimeters that are close, so if you want to explore. But you might also want to know more about the state data. So we can remove that one and do the states. And we colored the states based off of the number of fires in a state. So just from this, you can see, have a good idea of where are the fires this year, or where have fires been this year, I should say. But we also added a pop-up to it. So you can click on it and get the actual number of fires that were in this state. We can also add the fire perimeter data too. So you can have both on the map at the same time. If you wanted to zoom in from there and explore, right? Maybe you're curious about the Palisades fire, how much money was spent fighting that, right? And this is just the cost of fighting the fire, right? Almost $209 million. But you can see that just by leveraging Python and getting this data that is actually easily available to us, that you can start to explore and see the different things of something that I feel like, especially before I was kind of in the field, was kind of out there and unique and unobtainable, right? But this data is available. It's, while it's complicated in the terminology and there's a lot of it, it's accessible, right? It's accessible. You can do something quickly that really allows you to explore something you're interested in, right? So I would challenge you to take some of this data and play with it. And there's different data sets out there for, historical, there's the active fires, but maybe you want to play with it with actual weather data too. And you want to look at something like that. You can also get some of the fires on there. You can ask me, I can find the link for it. But you can get fire, they have the data from time, right? Maybe you want to do some type of time series with it and map that, and you can do the progression over time, right? So I just want to challenge you to really take the data, play with it, because it's out there and it's accessible, and I think it's interesting. But that's all I have for you. Thank you.